this is a long division problem because I'm dividing by more than one term. It's going to be an x minus 2 divided into 2x squared plus x minus 9. And then I say, what do I multiply x by to get 2x squared? And you would say 2x. 2x times x, 2x squared, 2x times minus 2 minus 4x. Notice how everybody lines up. Then you subtract, which changes the signs. So the x squared drops, and I'm left with 4x, bring down the 9. What do I multiply x by to get 4x? And you would say, or 5, I'm sorry. Yeah? 5. What do I multiply x by to get 5x? You would say plus 5. 5 times x is 5x. 5 times minus 2 is minus 10. Then you complete the process, change the signs, don't stop ahead of time, and you notice that you have a remainder of 1. So this would be 2x plus 5, a remainder of 1, or 2x plus 5 plus 1 over the divisor, just like you would do in arithmetic. Either way. Like I said, I kind of like that one, unless there's something specific I need this for. In calculus, it's more than likely I need this for something specific. And in fact, in college algebra, I think we use it once. Yes?
So, I see when you're coming down here, when you go to the negatives, like the 2x minus, then you have the negative 4x.
Mm-hmm.
So when you flip that to a positive, it's because of the negative.
Correct. Because of the negative, no. Because we're subtracting. So remember when we were doing this, we were using, and we started with the arithmetic issue.
So we only flip when we're subtracting.
You're always subtracting. And the issue is when you're subtracting and you've got more than one term, then everybody's sign changes. So that says if I were to subtract, I'd have a 2x squared minus 4x. It says subtract this from 2x squared plus x. If you subtract, the 2 changes to negative, the 4 changes to positive. So all of the signs have to change. And that's primarily why when I'm doing division, I don't write over top of the sign. I don't write on top of the sign. I'll write over top of it and then circle it. Then that reminds me that I have performed the subtraction, which means changing the sign. You change the sign on everybody. So again, all the powers are, this should be, by the way, a y squared and not an x squared, so.
I was about to say,
I know, that was a cut, and that's what happens when you cut and paste. Because everybody else was x's, that was the only problem, was a y.
X squared, and that would be more complicated.
Yeah, we wouldn't want to do that, no. Don't want to do that. So this would be 3y minus 1 divided into 6y cubed plus 7y squared plus 12y minus 5. All powers are accounted for. 3, 2, 1, constant. Now, I could make up problems whose leading coefficient is 1 in the divisor from now till the cows come home, because that's easy. But if I had like a 3x minus 1, I couldn't make that problem up, no way, no how, because I could end up with fractions. And so always if you would ask me to work a problem, I'd have to go look one up, because I can't trust myself otherwise. So as I look at this, I say, okay, so what do I multiply 3y by to get 6y cubed? You would say a 2 and a y squared. So I know for sure I've got the right one. 2y squared times 3y is 6y cubed. It's the same as the one that's there, because when I subtract, it's going to go away. And then 2y squared times minus 1 is a minus 2y squared. Then you subtract, which changes the sign, and both of them change. So it's 9y squared plus 12y. If I've done it correctly, every one of these leading terms that's coming down is going to be a multiple of 3. Because otherwise I'd end up with a fraction. And 9 is a multiple of 3, so we're in good shape. What do I multiply 3y by to get 9y squared? You'd say be a plus a 3 and a y. So 3y times 3y is 9y squared. 3y times minus 1 is minus 3y. And then you subtract, which changes the signs. The squares are now gone. So this gives me a 15y, and then I'm going to bring down the minus 5. What do I multiply 3y by to get 15y? That would be a 5, and it's a plus 5 because 15 is positive. 5 times 3y is 15y. 5 times minus 1 is minus 5. Then you subtract. The y's drop out, the 5's drop out, remainder of 0. It divided evenly. So my answer is just this guy right here. Now, when I take a look at this guy, I notice he doesn't have a squared term, so I'm going to put a placeholder in, which is a 0x squared.
Oh.
And 0 times anything is 0, so it just leaves a placeholder. So x plus 4 divided into 2x cubed plus 0x squared plus 6x minus 4. So cube, square, x, 4. And then what do I multiply x by to get 2x cubed? You'd say 2x squared. 2x squared times x, 2x cubed. 2x squared times 4 plus 8x squared. Then you subtract x cubes. Notice I did get an x squared term. So this is minus 8x squared. Bring down the next term, plus 6x. So each time I go down by a degree. What do I multiply x by to get 8x squared? You'd say minus 8x. This would be minus 8x squared minus, oh ugh,
Keep the screen up.
32x, no. Thank you. Minus 32x.
Just get split from there.
I know, plus. Probably got this problem from your book. And this gives me 38x, and then I bring down the minus 4. What do I multiply x by to get 38x plus 38? So that gives me 38x plus 4 times 38 is, I think, 152, isn't it? Not because I'm smart, but because I did the problem last hour. So this is minus, and minus 156. So I'm going to have a remainder of minus 156. Ugh.